So there's one more question I wanted to look at in section 1.6. Of course, others have been assigned to you, but hopefully I've covered examples that help you with those. And I'm looking at number 31, is on page 32, and it's the section Inequalities, section 1.6, but I'm on page 32, question number 31. So they give us a question to solve and graph this inequality, and it's a compound inequality because we have two inequality symbols. But they give us three different domains, so there's really three questions involved with this. But the work to do is actually the same, work that you would do, and then your graphs are going to be different. Your answers will be different based on the domain. So let's start with just isolating x. Now this is an absolute value, so we really have two expressions to solve here. Remember that whenever you have an absolute value, you have a positive and negative inside the absolute value. So I'm going to write two of these. One of them I'm going to write exactly like this, and I'm not going to change the sign. I'm just going to drop the absolute value symbols. And the second one I'm going to write with the inside of this negated. So the first one is 3 is less than or equal to x minus 2, which is less than 5, where x minus 2 is between 3 and 5, 3 included. And the second one is negative x minus 2, plus 2 rather, excuse me, because I'm negating every piece of this. So it's negative x plus 2 is less than 5 and greater than or equal to 3. Okay, so to isolate x here, we're going to add 2 to both sides. Sorry, all three sides really, all the parts here. And so x is going to be greater than or equal to 3 plus 2 is 5 and less than 7. Okay, so it's between 5 and 7. And the second one here, we're going to subtract 2 from all the parts here, right? We have two inequality symbols, so treat them like equal signs. Right now I have negative x in the middle here, and I have 5 minus 2 is 3, and I have 3 minus 2 is 1, and I'm going to copy those inequality symbols. Now the last part here is to get rid of this negative, right? We don't want the negative on the x, so we're going to divide every term or multiply every term by negative 1. However you look at it, it's the multiplicative inverse, and we have to flip the direction of the inequalities whenever we do that. Whenever we multiply or divide by a negative, the direction of the inequalities flip. So this is now x is greater than or equal to negative 1, and x is greater than 3 but less than negative 1. Okay, so x is between negative 1 and 3. So now for A asks us to graph all the solutions that are real numbers. And again, real numbers are all the numbers on the number line. And remember that I really have two sets here, right? I have this one, I'm going to box it, this one to graph, and this one to graph. Okay, because both of these are solutions. So for A, if x is between 5 and 7, so say here's 0, here's 5, and here's 7, but it's greater than or equal to 5, so I'm going to shade that in, and actually I think I'll use a different color here if that's okay. We'll shade in 5, but we'll keep 7 open, and we'll shade everything in between. Those are solutions to that. And this one down here, x is less than or equal to negative 1. So where's negative 1? Negative 1 is over here. And 3. Oops. That's a negative 3, isn't it? Yes, it is. Thank you. For anybody who caught that, hope you did. Should be negative 3. Why is it negative 3? Because we divided a negative 1 out here, so it should be negative. Okay, so now we're going to graph that. It's less than or equal to negative 1, so we're going to shade in at negative 1 and shade less, and greater than negative 3. Here's negative 3, so we are not including 3 in the solution set because it does not have an equal sign. Okay, so for our first domain, the set of real numbers, that would be what our solution would look like and our graph would look like. So B changes our domain, so now we're sort of in a different store where we don't have all the real numbers, we only have integers. Okay, so the only solutions will be integers, okay, but we're still using this right here, and we still have 0, and our endpoints are 5 and 7, and integers include 5, 6, and 7, and over here we have negative 1, negative 2, and negative 3. So the integers that are greater than or equal to 5 include 5, 6, and less than 7 does not include 7. So, sorry, I was not shading that. don't shade that. I'm just going to reinstitute my line here and mark 7 there. 7 is not shaded. Why is 7 not shaded? Well, it's not in the solution because it's not included in the equal sign. It is an integer, but it's not included in the solution. Remember, 7 is not a solution up here. It's not a solution here either. What about on the other side here? X is less than or equal to -1 and greater than -3. We need the integers that does that. Less than or equal to -1 includes -1, includes -2, but does not include -3. So that is what my solution set would look like if I graphed from the set of integers. And then the final set or domain is the set of positive numbers, and this can kind of help us. The set of positive numbers are only the ones to the right of 0, and it actually would kind of look just like this, but not this, because the set of positive numbers includes their numbers, so that includes any kind of number, rational, irrational, fractions. So we're going to put our scale here again. We have 0, we have 5, and we have 7. 6 is in there too if you want to put it. But so the positive numbers would again look just like this part. It would be positive 5 up to and stopping at 7. Open circle there. Okay. But why wouldn't it be over here? Because these are negative, and I'm not in a store that sells negative numbers. I am only in a store that sells positive numbers. So for the final part 3 or C would be just these right here, from 5 up to but not including 7. That is an open circle. Let me just make that a little more clear that that is an open circle at 7. Okay, so please let me know if you have any questions. Feel free to shoot me an email. Love to hear from you. Hopefully this helps. See you soon.